Hello, so welcome to our project. So we will get started with our project, which is football match analysis and prediction using machine learning and VAP framework. Okay, so I will go ahead and explain the basics of our project first. Okay, so here are the things which we are gonna do in our project. So it's basically we are gonna explore how machine learning techniques can be applied to analyze football and matches and predict the outcomes along with the VAP framework. Okay, so yeah. So things covered in this section are the pre-processing of the data sets. These are the things which we are gonna pre-process. Then we are gonna convert our data set into spiral format. Then we are gonna generate feature, do some feature engineering and ADF for our data set. Then we are gonna explore SPDL and generate some more features. After that, we are gonna save the features, train our ML model. By splitting first, we will be splitting the data sets. Then we will train our baseline classifier, baseline model, which is XGBoost. After that, we will be estimating their probabilities, evaluating their probabilities. Then we will do an optimization for them using the hyperparameters. Then we will be constructing a final classifier. After that, we will be analyzing our models with the VAP framework, I guess. And we will also do SAP analysis for model predictions. So I guess these are the things which we are going to perform in our data. Okay. Libraries here. After that, we are mounting our Google Drive into our Colab. After that, we are importing our libraries. Then we are turning off the unnecessary warnings which we don't require. Here we are reading the JSON file. We are reading it in our binary form. Okay, whatever this is a function which is used for reading the JSON file. We are opening the file and opening it in binary form. And after that, we are gonna read our file and get the value and decode our JSON file using the Unicode escape format. Okay. After that, we are like once we have created the function for reading the JSON file, we are gonna store them in we can store them in JSON team, and after that we are gonna convert that into our data frame. Then we are gonna represent the first 10 values of our data frame. Okay, this is just to so that our data frame is working or our JSON file is properly formatted or working or not. Okay, so here you can see our data frame team consists of team, city, names, their ID, official names, and area and types. So yeah, after that we are saving it into our h5 file format using the key teams. This we are gonna retrieve later. Okay, and then again we are doing the same thing for the players also. Okay, you can see we are using the player JSON to read the files, then assigning them inside one player, and then just using the first 10 of them. Then we are saving them in data h5 using player ID. After that, we are using the competitions, like we are creating a list here which have different competitions. Okay, we can uncomment this and it will add more instances in our data sets. Then we are gonna create one data frame which is named as match. Okay, so for competition we are running a loop which will replace um, empty spaces with this dash sign. So after creation of the empty data frame, we are seeing this loop which rotates around the competition, whichever competition we are seeing here. Okay, replacing it with a blank like this ones. Okay, with a dash mark. Then they're constructing the file name for the competitions. They are reading the file JSON files, storing them as data frame inside data frame matches, and then they are creating a list of all the they are creating all the data frames into one data frame matches. Then they are combining all into one single data frame and then representing the first 10. Okay. After that, they are saving all into one matches dot h5 dot matches. After that, we are doing the same thing for the events also and storing them inside. The same thing is done for the events also. Okay. And then we are finally converting it into our SPDF data format. You can see here. After that, we are gonna see generate features part. So after saving the data, let's move into some exploration part and feature engineering. First, we will be loading our data set. After that, we will be mapping the teams like the home team and the away team. Okay, so the team name mapping, what it does, it creates a dictionary called team name mapping where the keys are team ID and the values are team names and the data frames. Okay, after that, we have data frame games, DF frames, home team name. Like this maps the team name, like the home team name. This line creates a new column in the data frame games called home team name. It does this mapping by creating the home team ID to its corresponding team name using the team name mapping dictionary. Then the data frame games away team name. This again creates a new column in the data frame games calls away team name by mapping away team ID to its corresponding team name. Okay, so yeah, we are doing this. After that, we are just displaying our DF games here, like what are the game ID, competition ID, session ID, game date, home ID, team ID, away team ID, like we have defined this one. Okay, after that, we are setting our home team name and away team name as Belgium and Japan to see what competition have been played between them. As you can see here, we can see game ID, competition ID, session ID, game date, home team ID, everything is here. Okay, so here we are setting the game ID after that. Okay, so moving to next part. Here you ask me what is the SPADL format. So here we get to analyze different types of action like the pass, cross, throw in, free kicks, corners, take ons, tackle, interceptions. These are the things which we can like there are these actions which we can analyze using our SPADL dataset. Okay, so basically we are converting our dataset into a standard form of SPADL and then we can just analyze different types of actions which are taken during a match. Okay, so here we are again creating, here what we are doing, the first line is used to open the SDF file which is in spadle.h5 format and assigns it to a variable spadle. After that, the data frame action is reads the data from the games with game ID in the SDF format and assigns it to data frame action. Then the game ID is assumed to be defined earlier. Like here we have defined our game ID, as you can see. Okay. After that, we are merging some actions like the results, body part, player, and teams along with the actions, data frame actions. Finally, we are resetting the index and renaming our index to action ID. As you can see it here, we are renaming our index, like we are resetting our index and renaming it to action IDs. Okay, this line is used to show the first five actions of during the match. Then this is the nice time. So basically, in our data set, the timing is stored after in different formats, like the time elapsed from first half, then the time elapsed after the second half. So like the time after the second half is stored as 10 seconds or 10 minutes or 15 minutes. So it's after the second half. So basically we have 45 minutes of our first half, then 15 minutes of the inter time. After that we have 15 minutes of extra time, then we have second half and extra time if there is anything available like that. That's what we can see here, like the period ID if one more than two, then we add 45 for the if we have more time than two, like if we have second half, if we are in second half, then if we have extra time for 3, then we add 15 minutes, and if we have extra time for 4, like the extra time after the second half, then we add 15 again, and after that we get the times in second and divide it by 60 to get the minutes. So basically it will like if 75 seconds are elapsed in the match after the second half, then the function will calculate the minute as 45 plus 15 plus 0 plus 1. So it will total come to 61 minutes, and the seconds will be 15 seconds. So it will return a string of 61 minutes and 15 seconds. So as the name implies, is used to create a nice time basically. Okay. After that, we can see we have something as action names. So the action name creates a new data frame by combining the information from the pre-existing data frame using a nice time, sort name, and type name. Okay, like which type of the action is taking place. So these things are appended in one column named as action ID. Okay, along with action ID into action name. So yeah, after like if suppose if we have row as action ID is equal to 121, and then we have nice time as 61 minutes and 15 seconds, and if we have sort name as player A and type name as pass, then the function will construct it as 123 followed by a question mark, then 61 minutes 15 seconds, then followed by a hyphen mark, then a player A, and then followed by pass with gap in between. Okay, so it is appended into action name. This is later used to run the widgets, as you can see it here. Okay, so this is used to run this thing. Okay, let's proceed. Plot actions. So what does plot actions does? So the plot action creates a soccer field plot with visual representations of actions during the football match. So let's see what are the arguments inside the plot action function. So the plot action, the first one has the location. Location contains the start and the end coordinates of the action, like what is the starting point, what is the x and y of the starting action, and followed by what is the ending x and y for the same action. Like if we have pass, so the position of the player in before pass and after pass. Okay, so he will be displaced to some action. No, that's it. Then we have action type, like what is the type of the action which is taking place, pass, shot, or tackle. Then we have team, whether it is a home team or away team. Then we have result, whether it's a goal scored or pass completed, whatever it is. Then we have labels, like what is the label, nice time, team, type name, sort team name. After that we have label title, uh, ti- uh, then we have level title as time, action time, player, team. Then the zoom inability is set to false and figure size is set to 8. After that we have another function which is named as plot action from the action names. Okay. So this function takes data frame actions which we have already created earlier and the action name. Okay. The purpose of this function is to visualize subset of football match action based on a specific action name. Okay, we will see it later what it means. Here we have interact manual which is powering this plot, which is powering the 2D plot, which shows the action which is taken during different players. Okay, like the first one, it is passed by A Witzel. Then we have second action which is passed by J Watong. After that we have third action, fourth action, fifth action, and sixth action. So there are different actions which are taking place. Okay, which is named as Viconi pass. The same way we have, like this is for the one match which is taking place between the Belgium and the Japan. So yeah, let's first see what plot action from action name does. So it First, split the action ID based on the column mark, which you can see here we have used to make like the action ID, and it splits the action ID using the column mark. After that, it fetches the nice time sort name and the type name. Here you can see it fetches the type, like it is stored in the data frame action to plot, and then it is passed to action plot actions. You can see here we are getting plot actions here, and these are finally moved on to interact manual. And here you can see the different plot actions. It is in the same way like the nice time, then the short name of the player, followed by the action which is taking during the match. So every action during a match is analyzed here using this 2D plot. Okay, we can run this also. After that, let's move on to feature engineering part. I hope you get this part also, like what we are doing here and how we are analyzing everything, like how we are analyzing the different moves which are made by different players. I will just go on and run this project and show you how it's working. Okay, till then, let's move to next part. So the codes are running in background. Let's move on to next part first. Feature engineering. Okay, here we will be creating start location, end location, action time, party parts, results, and time in the match. Okay. Along with this, we will use other features also. So here first we will see the action ID, and again plot the action with a single ID. This is just to show this is to plot. That's it. Then here we are tabulating everything in like what other things which are happening with the same action ID. Okay. What are the data which are present in the same action ID. After that, we are representing the location of the ball. Okay, so we are defining pitch length and pitch width. After that, we are defining our start xy and xy for the specific action IDs in our action data frame. Okay, here it is transposed. Okay, like the we can represent the same thing without this, but it will be in a long line. Okay, by it will be in a one row only, so it will be kind of difficult to understand. That's why it's just transposed, so we can view in an easy way. That's it. There's nothing very big in this. Okay, action name which we have created. Okay, pitch length and width. Then we have our data frame action. These are used to normalize the location for the ball. Okay, so first the for side in start up to end, it starts a loop which will start with side is equal to start and end with side is equal to end. After that, we have a key which is equal to side, means whether the key x is start or the end. Then after that, we have a data frame action with the normalized key. Okay, like this is stored here, and this is finally stored in our data frame action along with the pitch length. This line creates new column in data frame for normalized x and y coordinates. The coordinates are normalized by dividing the length of the pitch length and pitch width respectively. After that, we are compiling them into a one data frame into our data frame and displaying the normalized start x, start y, index and y. Okay, according to our pitch length and pitch width. After that, we are doing the same thing with the goal x and goal y. The goal x is equal, as you can see, is equal to pitch length. We are taking it as pitch length, and goal y we are taking it as pitch limit by 2. After that we are again starting one loop for loop which start with side is equal to start or side is equal to end. Then there is one difference x is equal to, like, what is the difference? This line calculates the difference in x and y coordinates between the goal and the start end points. Okay, same for the x-axis, then y-axis, like for which side we are taking for start. If you are taking for start x, like this, if you are taking 0.71, then it is here, and we are calculating goal x, what is the pitch length, and then we are start distance to goal. Well, like, what was the start distance, then what was the angle to goal. We are calculating the angle to goal here by using the difference of x and y, using the formula for this, like we are calculating tangent of the player and the ball, and finally the goal. So yeah, this is the formula we are applying to calculate the goal. Then this is the distance to goal, the formula which we are applying, and then again appending everything into our pre-existing data frame action, df action. Okay, so here you can see what was the start and what was the end. Finally our start distance, then angle to the goal, end distance, and angle to the goal, what all things are subtended by the ball. Okay, after that we are seeing whether it is causing any whether it is inside the penalty box or not, like if the player is running towards the penalty box or whether it's not present inside the penalty box or not. Okay, like we are doing we are doing calculations for penalty check. If you are interested, you can go ahead and check it in paper. Then we are representing different body part action types and result, like whether for each index, for each data, whether the clearance is done or not, corner is closed. Like we are taking everything at once and then labeling what things are done or what things are not done. Like for here, you can see there is a sort, and here we have passes. So yeah, for different ID, we will have different things. Like in one row, any one will be present, like any one will be true, other will be false. These are used to create the labels for machine learning. Okay, after that we have again one function which is named as add function type dummy. So this will create a new data frame. Like this function is used to create new data frame using the type name. In this new data frame, each value in the type name column of the data frame actions become a new column. For each action, the column corresponds to type name and will have a value of 1, and all the other column will have a value of 0. After that, we are merging this into our data frame actions to get the with the data frame of the variable dummy variable. This merging is done based on the index of the data frame, like left and the right index, which means that all the rows from the data frame actions will only match from the other data frame are kept, which are not matched are deleted, like all the NaN values are deleted. Then here we are performing the action, and after that we can see what is happening. We can again tabulate here, like transpose here, to see everything what things are contained, what things are consistent inside our. Okay, so yeah, we can do that. Yeah, I forgot. Like now you can see different things, like different actions which I took during the match with. Each action's been taken place along with the time stamp by whom and what was the action. You can very well interact with this to see which player did what things. Okay, so yeah. Now let's move on. This displays the unique values which are consist inside the body part, like the which body part is used to hit the ball, foot, other, or heads. Then these are the result names, like um, what happened during each action. Was it a successful, or what is a failure, or was it offside? Because you get to have extra idea. Okay. After that, we are checking it for ID 145. What were the body part names and the result names? Like what happens, what body part was used to hit it, and what was the result. Okay. So let's move on. Now we are defining some more functions here to add distance and the time which player played. Okay, so here we are calculating the difference between the end x and the start x and storing it inside difference x. Then the same we are doing for y end x and end y start y and storing it in difference y. Then we are calculating the difference covered. Okay. After that we are defining another function at time played. This is again stored in different format, like we have done this earlier also, where we converted the 15 second of the second half into the time from starting to the end. If you remember, I have explained this here also. Yeah, nice time. We are again converting it. Okay, for the template and storing them. Then we are storing the difference, x y difference, distance code, and the template. Okay. After that, we are representing the action. We are representing the field for the action ID 145. Okay. Here we are calculating the time taken for each action from the start. Okay. So this is for each action for 150, 140, 50 instance. Okay. So here we are running the loop again. The I intensity, it starts a loop that will run three times with I taking the value of 0, 1, and 2. After that, we are selecting the line using this function, which we have already calculated. Okay, so this line slices the data frame actions to plot, like for each iteration of the loop, we get one row of the data frame action starting from the row 145th and moving backwards. Okay. After that, we are plotting the action. For this, we have already earlier defined the action, which I have also explained here. Okay, so yeah, moving on. Like for three actions, three fields are created. Okay, after that, we are again defining some more features here. So this is basically used to create the what actions we have taken previously, like these are the number of the steps to get delayed, like the number of steps earlier to consider, and these are the feature which we are trying to consider in our feature list. Okay, so yeah, then after that we are creating one function here for our delayed actions, like delayed features, which are three steps before the main action has taken place. Okay, so here we are defining many things. So let's break up the things and get started. Okay. So this line creates a version of the data frame action, which is shifted by a number of the step from step 0 to 1 to 2, like from the number of the delays. The step function shift the value in the data frame period forward, like if it's forward, then it's gonna shift forward, or if it's negative, then it's gonna shift backwards. And the suffix is added so that the column names of the indicated numbers of the steps delayed are identified. Like without suffix, we will not be understand which step number it is. Okay, so here you can see from start x1 x and x1 y2. So these are the suffix with the number of the steps. Okay, I hope you get this, like the number of the step which we need to shift our data uh, our data frame in the actions, and finally these are getting concatenated, like they are gonna added to our delay data frame. Okay, so basically delay data frame will contain all the actions which are taken previous to the main actions, including all the period IDs, times, team, player, start X, start Y, index, index, everything like that. Okay, so yeah. So here we are just representing these things. That's why it's coming up. Otherwise, we can represent the whole thing also. Okay. So yeah, we are representing one number of things. Okay. After that, we need to invert the coordinates for the reverse team. Like for one team, it's in the same direction, but for the other team, we need to inverse the coordinates for them. Otherwise, the analysis will not be same for the both teams. Okay. So here we are gonna try to invert the coordinates for the reverse team. Okay. For the same teams, we don't need to do anything, but for the reverse team, we need to do. So yeah, let's run this notebook till here. Okay. So yeah, here the function we have created to invert the coordinates. First, we are considering the steps and the delays. Then we are considering on which side, like the start or the end. Then here we are reversing the inversing the coordinates for x. Then here we are inversing the coordinate for y, and then finally we are displaying the data sets. Okay. So by applying this function, the coordinates of the data frame features will be relative to each team performing the action, while the opposing team will be of the mirrored coordinates. Okay, you can see here. Yeah, we are getting it successfully for all the coordinates, and these teams are related to each other now. Like initially, the start was from the one end. Start was in the one end of the field, and the end was on the other end. But now it is relative for both. Like for team A, it's from their pole, and for team B, it's from their pole. Okay, so yeah, we have inverted the coordinates and then representing the features. After that, we have created one another function for the locations. So here we are again starting off with the steps and how much delay, like step like before one action or before two action or before three action, along with the side which we are playing. Then we are storing it in key, and then again storing them with the in the data frame feature. Okay. After that, we are normalizing x and y here. Then we are doing the same thing, like calculating the angle to the goal and the distance to the goal, calculating difference between x and y, and then storing this inside one, showing this inside one column with name of difference x with step like 0, 1, 2, whatever the steps are. Okay, like 0, 1, 2, whatever the steps are, we are calculating and showing them. After that, we are representing them. Okay, what are the like we are performing the same function, like whatever we have defined here, we are running here on our feature data frame. After that, we are representing the hits, which we are representing just the starting fives of them. Okay, then we are adding pre and post feature sequence, like the number, like what has happened in before, just before and just after the action has been taken place. So we are defining them here and doing them. Okay, then we are generating the features which all features we have already defined here. Okay, and some more also, like we are also generating the labels for the match, like the scores, whether the score was done or not done. Okay, and then we are defining coincidence, like what is the action, like the action before the goal. Now, just before the action was a successful in getting the goal or not. So here we are defining label for consents and label for scores. So these two functions are used for defining those. Okay, so here you can see for id 382, these are finally concatenated, like we are doing all. Okay, we are joining to the labels data frame. Feature data frame we have, you have seen we have created. Then we are creating another data frame with name of labels, and then we are viewing last 10 of the dataset data frame instance. Okay, here we can see for some actions it has lead to goal and for some it's not. Okay, so yeah, after that we are saving this into our dataset which we have already created. If you remember, this we have created in the first part only. Okay, then we are just showing it in the name game. Okay, here again we started merging everything, every features. Then we are creating one h5 file for our features and one h5 file for our levels, along with merging it in spdl format. Okay, so yeah, these are pretty much everything which we are creating for our features, like which we are doing in our feature engineering part. So I guess this was kind of complicated, but these are required features for getting our analysis using the machine learning model. So now let's move into our machine learning model. So again, we are reading everything from our dataset and representing the last 10 of them. Then again, creating a new feature list with all the features, storing them inside that. Okay, then storing the label inside the data frame labels for all the matches. Okay, earlier it was done for one match, now we are doing it for all matches. We are just installing scikit-plot library which will help us in plotting different functions. Then installing, importing some of the libraries. Then again, we are splitting our data set, okay, and finding mean of the y values and the y trade, and finding mean of train and test values. Okay, I guess it should be x. Okay, okay. So yeah, we are finding mean value for scores and concepts, like how much are the values, mean value for them. Okay, yeah. You can see here we are taking x as data frame features and y as data frame labels. Okay, and doing a difference between labels and concepts. So yeah, now we are trying to create our baseline model first. Okay, using these many features. we are trying to create our baseline model, and these are the two labels which we are gonna train with. Okay, so here we have defined one XGB classifier with log loss matrix, number of estimators are 10, and the max step is 3. Then we are fitting our like this, you can understand as training our model with our with the number of with which x train and y train. Okay, then we are performing some predictions here. So let's run also along with. So yeah, training the model. Then we have created a new data frame for predictions, and then for test values, we are for test values we are defining the probabilities and then appending them into our prediction data frame. Okay, these are just basic steps, nothing fancy here. Then we are checking what our predictions are for different values of scores and for different label values. Then we are gonna evaluate our probabilities. Okay, and compute brief score for brief score loss, because this is only metrics which are best suited for our task. Others are not suited because you cannot describe accuracies for this or precision for this. Okay, because we are doing something as probability. Okay, so yeah, they are running. Then we have started a grade classifier, grades are CV. Here first, a model CV, it initializes a empty dictionary to store train model for each level. Like we are gonna train different models to get the best hyperparameter for our model. Then here is we are this is used for the progress bar. This looks over each level and the level list like the constant underscore, and the T, TQDM function shows the progress, updates the progress bar which you see here. Okay. After that, we have initialized our model as grid set CV, and inside that we have placed our model XCB classifier. Okay, so it performs what grid search CV does. It performs iterative function to determine past hyperparameters, which we have said here, which we have done like written number of estimator 50 or 100 or max depth as 3 or 4. What are the best classifier? Like now, what grid CV will does? It will run it for max depth equal to 50, max depth equal to 4, 4 for number of estimator is equal to 50. Then it will again run for number of estimator is equal to 100 and max depth equal to 3 and 4, and then determine what is the best hyperparameter for this XGB model for with the matrix of log loss, like what is the loss for the model according to each hyperparameters, and then it will be fitted. Okay, and then like you can see here, for each estimator and depth it's getting different scores and determining what are the best, and the scoring used is barrier score here. Okay, The barrier, you might ask what is the barrier. So the barrier score, you can see it started. Okay, so barrier score, what it does, it measures the accuracy of the probability of predictions. Okay, it does not measures the accuracy, it measures the accuracy of the probability of the predictions, whether they are right or not. So it is basically appropriate for our binary and categorical outcomes. After that, the refit, what does refit does? So refit is the estimator using the base found parameters on the whole data set and then reports to the grid. Say we have set our verbals to 10, which means that more now, like every message is gonna get displayed here, which we will see in sometimes. Okay, and the number of job means the number of processor for which we are gonna allot here. So I am keeping it to one. Increasing it will just enhance the performance, or you can faster the process, but it may crash if you just do increase the number of jobs here. Okay, you can think of it as number of workers which are working inside a company. Okay, so it's the same kind of thing, but keeping it to 3 4 5 may crash the system sometimes, so it's better to keep it in one. Okay, we can try if we have more number of parameters here. Then we are fitting the model with our features and labels and then performing our grid search CV. Okay, so what does this function does, you may ask what this function does. So the model CV shows the model inside the dictionary with a label as their key. Okay, so we can access different models anytime, which are stored inside model CV by their labels. I guess you understand this. After that, we are again doing our probability estimation and then finally evaluating our model based on variance score. Okay, so yeah, we are doing it. After that, we don't have epochs here. Okay, so don't think of this place as epochs. After that, we are constructing our final classifier based on the scores. Okay. So here you can see the best parameters which are obtained are 4 and number of estimator for which it is obtained is 50. Okay. This is the detailed view of all the things which we are gonna get, with the grid search CV. Okay. So yeah, there you can see different sets of parameter used. Okay. So now we are getting the what are the values, like what are everything, what are the hyperparameters which are stored for our best model. So you can see here these are the sets of the hyperparameters. After that we are displaying it. What are the final scores for the model? Then we are putting up and using the best estimators. Then again showing it here. What are the parameters, what are the hyperparameters used for our best model, final model. Then we are gonna analyze with our view. So here the model creation part is complete. Okay. So now we are gonna analyze it using VAP framework. Okay. But before proceeding to VAP framework, we will just use shape to analyze our model, like what is saying and why it is saying, to understand what the models are saying, so that these things are getting classified. And before that also we are gonna see feature importance here. Okay, so yes, yeah, we have feature importance. Okay, so here we are installing save, which is a model explainer. Okay, then here we are installing some bunch of libraries along with our ignore warnings which are not required. Okay, then we are making one more model along with all the features now. Okay, earlier we were not using all the features because it would take a very long time to run. That's why now we are taking all the features to construct one model. Okay, like okay, so it's take a very long time to run. That's why for estimating those we used few features. Now we are gonna use it for the full features list. Okay. Yeah. So these are our final models, and here also we are. So these are the same things. Okay, nothing new here. Just one thing we have added here, and that are the feature importance for each prediction, like what things are being used for getting our features. So in feature importance, you can see that the most important feature is end distance to goal, and you can also understand that the lesser the distance, more chances of the goal. After that, we have end angle to goal, which is getting around 70. Okay, these are the F scores. After that, the start distance to goal in previous step to like two steps before, then one step before. So yeah, these are pretty much everything which are important for the classifier, the model to get classified for getting the predictions. Okay, so these are the feature importance. After that, we are investigating the same thing using the same model explanator, like what it does, what it says in the results, the most important things which it says in the results. Okay, so here you can again see it is end distance and the end angle to the goal. Okay, then the start distance to goal. So these are ranked according to their um, like how important these are, like according to their importance. Okay, so yeah, it is also giving the same thing again here. After that, we are again creating a data frame prediction, a empty data frame, then getting the prediction out of our model, and then storing the predictions in our, like, getting the predictions which are there, and then finally storing them with the labels. Okay, then we are loading the rest of the data set. Okay, then again we are making one another data frame actions, and appending all the predictions or actions in one data frame, which is known as data frame action predictions. Okay, so these are the values which we are getting, and then making a new these values will store the key predictions which are already there in this, which are grouped along with the game ID. Okay, after that we are storing them here data frame values, and finally we are getting like combining everything into one single thing, which is data frame all. Okay, after that, data frame values will consist of all the data frames which are stored in all the TFS means collection of all the data frames, and DF means data frames. Okay, so now we are resetting and sorting the values out using game ID, period ID, and time seconds, and then resetting the indexes. After that, we are like now it is a very big group. Now we are just showing the last 10 of them. After that, we are gonna rate the players using VAP framework. Okay, so let's start. Here we are creating a new data frame ranking using our existing data frame values with player ID, team, sort names, etc. So, and then we are grouping them using player ID, team name, and sort names. Then we are using a aggregation function to count, mean, and sum the values of the VAP. Okay, we are using these functions. Then we are sorting them using the VAP function in descending order, ascending first means descending order, and then resetting the index of all of them. Okay, so here you can see the index has been reset, and the player ID are also jumbled because we have reset the index of the. Here we get the team name, sort name, VAP count, mean, and sum. Okay. After that, we are reading our HDF file, like the dataset which we have created, and then we are So this line is basically a synchronizer to locate all the games which are present in all the game ID which are present in DF games are also present in the DF player games. Like what it does is first compare these two and whether the dataset here in DF player games with game ID are present in DF games with game ID or not. If it's true, then it is stored here. Otherwise, if it's false, then it is filtered out. Like if it's false, like if it is not present here, then it is filtered out. Okay, and the final result are stored here. So it's basically a synchronizer used to filter out the things. And then here we are creating another data frame with name of data frame minutes played, which will contain the players and the minutes they have played, as you can see here. Then we are grouping them according to player ID, then applying their sum, and finally resetting them, resetting the index or resetting their index. Okay, so you can see here. After that, we are taking new data frame for the players played 90 minutes. Okay, so here first we are creating the DF ranking P90, which is made using our pre-existing data frame PDF ranking. Okay, for the number of the minutes played. Okay, like we are merging these two data frames and creating a new data frame DF ranking P90. After that, we are making new column inside DF ranking P90 VAP rating, which is calculated using the DF sum, which is the value of each, like the whole value of the player multiplied by 90 for 90 minutes, and then divided by the minutes played by the player. And then finally the action P90, like the number of the action or the number of the VAP counts which are considered during 90, using the during 90 minutes by the number of minutes played. Okay, then we are considering minimum threshold to be 450 for a player to be like very good one. So here we are choosing only players with at least 450 threshold of minutes played. Okay, after that we are sorting out the things in descending order. We're using the VAP rating and then showing the first 10 players according to our VAP ratings. So here you can see the first in the line comes with the Lionel Messi and then San Barbara, then Bakamova. Okay, after that we are gonna perform quantity quality trade-off for our football matches using the best players. Okay, so here we are first plotting a figure of size 20 is to 10. Okay, you see it here. After that we are converting the ranking with mean and x and p90 into list of x and y so that we can plot it here. After that we are considering the name of the players with 100. Yeah, so we are plotting them. Okay, yeah. After that we are considering the name of the best 5 players according to our data set which are here. Okay, so you can see. After that we are splitting the first part of their names, like for a Lionel Messi we are like just removing the things before her and considering only Messi. Okay, and then annotating them in center. After that, for best player, we are considering their y and x value so that we can create a axis around them to mark of the best player. Okay, what are the best values? After that, we are plotting it. You can see here. Then we are just plotting the rest of the members here and putting on some labels here. Okay, I guess you got that. So yeah, we are doing a quantity or quality trade-off here. Okay. After that, we are gonna perform some risk-reward trade-off analysis, which we have done here, and then plotted it in the same way as the earlier, for which the Messi is the top scorer again. Let's see what we have done. For that, we have created a new data frame which is named as risk. Okay, and from the value data data frame values, we are keeping the values VAP value along with the index IDs. Aggregation function is the sum value. Okay, the column name is result name, and can be either success or fail. After that, we are taking, yeah, okay. After that, we are taking risk. Yeah, we are resetting the index. Then we are trimming of their last column. Then we are merging all the whatever data frame we have created with all the number of minutes played. Okay, number of minutes played. Then we are considering the results and number of successful results per 90 minutes of the play is calculated using this line. Okay, so yeah, and this calculates rows. Okay, this remove rows, not the columns. Sorry for that. So yeah, we are calculating the data frame using the data frame risk. After that, we are sorting out using the minimum threshold, and based on VAP rating, we are calculating the risk for success and fail, and then sorting out the values using the fails. Okay. After that, the same like earlier we have created here, the same thing we are doing here to plot risk reward ratio. Okay, you can see here the most scorer is also Messi and San Barbara longer. Then we are gonna calculate rating per action type. Okay, so yeah, so again we are creating one data frame. We are gonna create one pivotal table. This pivotal table are indexed by player ID, short names, and team name, and its column are unique in value like type name. You can see here. The aggregation function which we are using is some of the VAP values. Okay, and we are filling the on the we are filling the NaN values using 0. Margins are true, and while margin name is total. Okay, then we are resetting the index, removing the last row, then merging it with the actions and minutes played, and then again doing the same thing. This will calculate the number of actions taken in the in 90-minute period. Okay, after that we are just displaying the first 10 hits for the different players. Okay, so like what which are the best players, like here we can see San Barbara, then Messi, Sanson. So these are most cost effective, like these are the most scorers for, sorry, these are not the most scorers, but these are most valuable players for the team because they can assist in corners and dribbles. So basically, a least value of fouls, also free kicks. So basically, all in all, overall performance of San Barbara is above Messi. So this kind of analysis we can do. Lionel Messi can be a best scorer, but overall best performer for the team is San Barbara. So yeah, this completes our project. This was quite a long project. As you can see, it also took a very long time to run. So yeah, I hope you understand everything which I have tried to explain here. Everything is working here. So I hope you understand everything I have tried to explain there. So thank you.